Okay, this video is for my A-level students. We had a look at this paper today, 25th of May 2017. I said that if I got a chance I would record a couple of videos going through a couple of the questions in the paper. So here it is. Okay, first of all, this question is important to note that D is a silicon diode here. That's going to be important later on. So if you were to measure the voltage drop across that, if it's forward biased, it's going to be 0.7 volts. Determine the values of the quantities listed below, the combined resistance of the two 2K resistors. Now, because they are equal value resistors, we can just take one of those and divide it by the number of resistors. So in this case, RT is going to be equal to 2K divided by 2, because there are two of them, so that answer is 1K. That's the answer. Now that's by far the easiest way to do it. Just so you know, there are other ways we could do it. So if you have two resistors in parallel, if they're not of equal value resistance, you might like to use this method. RT equals the product to multiply each value together over the sum. So in this particular case, and remember I wouldn't advise this, I would just do it 2K divided by 2, but if you want to know about this, product over sum, so it's going to be 2K times 2K over 2K plus 2K. In other words, 2 times 2 times 10 to the 6, because it's times 10 to the 3 times 10 to the 3 there, over 4 times 10 to the 3. Okay, and then so that's 4K, okay. Right, too many K's there. So 2 times 2 is 4 times 10 to the 6 over 4 times 10 to the 3. So 4 divided by 4 times 10 to the 6 minus 3 equals 1 times 10 to the 3, in other words 1K, which is exactly the same answer as we got there, but a hell of a lot easier. Another method that you might want to do with an unlimited, remember this is just two resistors, an unlimited number of resistors, you might recall that the reciprocal of the total resistance is equal to the reciprocal of the resistances. So R1 plus R2 plus whatever you've got. Okay, so let's do this. 1 over RT, that's the total resistance, the reciprocal of 2K plus the reciprocal of 2K equals, now what you can do, well in fact let's just do it this way. So that's going to be 2 lots of 2K, okay, and then that, remember that's 1 over RT, flip them up the other way, so then we'll have RT over 1 equals, and I'll flip that one over, 2K divided by 2, because it's divided by 1, yeah, that's fine, we just get rid of that, equals 2K divided by 2 is 1K. Okay, but just divide 2K by 2, far easier. Right, on to the next one then, the combined resistance of all three resistors, so these three here. Now resistors in series, you just add them together. So we've already calculated the equivalent series resistance. The equivalent series resistance is 1K there for this, and so that we've got 1K and then we've got another 1K, so RT equals 1K plus 1K equals 2K. Simple. By the way, I do recommend when you're answering these questions, okay, these are only one pointers, but sometimes you might pick up a mark showing working even though you got the wrong answer. I always show the working anyway. Next one then, I. So I is going to be the total current that's flowing down through here, and how are we going to do that then? So we know the voltage. We know the potential difference here, remember that's 15 volts above ground here. We also know the voltage from this point as well. Hopefully you can see that that's going to be 15 volts minus the 0.7 volts. So bearing in mind that we know the voltage and we know the resistance, we can then calculate current. So the current I equals V over R, so that's going to be 15 minus 0.7 over the combined resistance. We already said that was going to be 2K, so that's going to be 14.3 over 2 times 10 to the 3. And feel absolutely free. I'll do this on the calculator just in case people aren't confident. So sometimes I see people not confident with the calculator. So 2 times 10 to the 3, 7.15 times 10 to the minus 3, 7.15 times 10 to the minus 3 is actually milli, and it was milliamps we were working out the current. There's the answer there. Do circle your answer. Sometimes it's not clear what your actual answer is. V1. Now, what's V1? Okay, well, V1 is this difference between this point and this point. Okay, don't confuse. It's not like from there to there. It's from these particular points here. Okay, from there to there. So, to do that, well, we know the resistance between there and there. We know the current between there and there, because remember, Kirchhoff would help us understand that the current going into this node will be the same current coming out of this node, same current going in, yeah, etc. Okay, so excuse me. So the voltage, so V equals IR, and we know the current, so the current is 7.15 times 10 to the minus 3, that's current, times the resistance. We know the resistance between this point is 1K, so times 1 times 10 to the minus, not minus 3, 3, because that's 1K. They effectively cancel out. Okay, so then we've got 7.15 times 1, 7.15 volts. Hopefully you're keeping up so far. Okay, V out. Now, if we know the voltage there, then we must also know the voltage between there, because the sum of the voltage drops is going to equal the source voltage. So the V out is going to simply equal 15 minus 7.15. Oh, what do I write? 7.18. I'm not thinking there. 7.15. Okay, so 7.15. So that's going to be 7.85 volts voltage out. Okay, hopefully you understood all that.